Okay, thank you. So a little maybe confusion. I think that they have the title of my talk sort of might have got mixed up. We're totally 100% going to be talking about Kubernetes today because that's what everyone talks about. So I'm going to talk about it. I'm not going to get paid to talk about Packer, whatever that is. But hello and welcome. For those of you that saw the title of the talk, you might have thought, nah, that's super boring. So there's probably like tens of people here as opposed to the hundreds that we might have expected for other talks. But what I want to talk about to those of you that are sticking around is this really awesome tool called Kubernetes. And I think it's this ideal enabler of really good architectural practices. But do take heed though, this isn't just a talk for folks who are super far along in their fancy cloud journey. It's really a talk for the every person, those that are early in their cloud journey, or maybe not in that journey at all. And so without further ado, let's jump right in. So if you're not familiar, Kubernetes is a container orchestrator, which means that it can take your tiny little Alpine Linux or your giant Java monolith images, and it can make them, in my notes here, it says planet scale. That's what I have in my notes. I don't quite know what that means, but that's what it does. So one of the most exciting things about Kubernetes is how many moving parts there are. When you look at this diagram, look at all these little icons. It's like a 5-color, 1,000-piece puzzle to solve, right? And it's totally not scary at all to lose one of those 1,000 pieces. And the constant threat of death by 1,000 node failures is actually something that gives me life every morning. It's thrilling. Kubernetes is also a perfectly portable machine and platform until it isn't. And if you're going into a major public cloud, you get to have fun bringing your own load balancer, service discovery tooling. Otherwise, your apps can't even be reached from outside the cluster. It's super exciting to have to deal with that every single day of your life. Kubernetes also has these really neat abstractions for automatically scaling these deployed applications and even the machines in the cluster. And so really quick, I wanted to show you how to use the really excellent CLI so you can see what's going on across your cluster. So here I just have a command line example that I typically run to check on the status of something. So you can check on the status of a scaled application by running your Kubernetes or kubectl get deployments of apps. I have alias for K, and you can see here that I have 10 different copies. Well, that doesn't look right. Okay, but that's okay. We can debug this really easily with the same CLI API that Kubernetes provides to us. It all sort of fits into this nice little package. Okay, so we're looking for the other 7 pods. And wait a minute. I thought it just said that these 3 were ready. Why are they saying that everything's erroring out? Okay, so it's fine. Didn't plan on doing live debugging further than that, but this is cool. It's a learning experience. You can see what the administration process is like. So what's the #1 problem in development of infrastructure? It's DNS. Right? DNS is always the problem. So let's see if that's the case in one of these. So if I run an exec into the container, click. Yeah, so if I look at my etcresolve.conf, I can see that my name server here is an internal name server. And so let's change it. Let's change that name server to Google's main DNS server, and that should always work. And we'll see if that changes anything for us. Okay, so Kubernetes makes that really easy because all I have to do is just connect into a container. I can add Google's name server into the etcresolve.conf. I'm going to make sure that that's what I expect it to look like, and it is. And we're going to run one more exec interactively. We're going to ping google.com. I'm using google.com's name server. This should always work. What? What is going on? Okay, you know what? That's okay. That's okay. We just need to go out and we need to find a different cluster DNS provider, right? Because it's probably broken. It's fine. We'll find another one. Ours is trash. All we have to do is look at the immensely helpful and not at all swamp-like CNCF diagram, and we can find a replacement over there. So I'll just okay. No, you know what? I'm sorry. HashiCorp couldn't pay me enough money to be here for this talk. I'm done. Kubernetes can suck it. I don't know. So a little bit dramatic, but I can guarantee that a lot of you have been in that exact same scenario before, whether it's short of quitting your actual job, or if it's dealing with Kubernetes or another different kind of platform orchestration tool. These things are just very complex. And to be clear, I really do think that Kubernetes is a cool piece of software. I've been using containers for a really long time. I've seen Kubernetes get better all the time, and it really can deliver on these promises that it makes as a platform, especially for developers. It can be this massive boon to delivery and velocity. But it's a really thick abstraction, right? And along with these other modern cloud native tools, it can require this massive amount of human capital to learn and to reason about, to stand up, to maintain, to develop and debug. And all that human capital doesn't come cheap, neither in terms of dollars nor the hours that it takes, right? And sadly, we've collectively become really used to these super leaky abstractions in architecture like Kubernetes and friends. Now, I'm not old enough to myself to remember this, but I always hear that it's been this way where you'll have these cycles of overheating on new tech revolutions, and you'll have these corrective cooling off periods that follow when things get too hot. And when I look at the state of systems today, I can't help but try and evangelize the need for another one of those cooling off periods as a correction. We're living in this time in tech where everything seems to have to be cloud native, containerized, serverless, and whatever other buzzwords you can scrounge up. And in reality, all of these services and tools run on more traditional operating systems at the end of the day, even if that's invisible to you. Apologies. And so in this cooling off period, what I propose the logical step back to take is towards good old virtual machines. And that is where HashiCorp Packer comes in. Packer is this fascinating tool that builds virtual machine images, which almost sounds too simple to be valuable in 2021. But I assure you, as we'll see, there's a lot more value in those words than you might imagine. At its core, I also think that Packer solves for this problem space that maybe even Mitchell Hashimoto might not have intended when he made the first public commit in 2013, and that is that it can facilitate the very first realization of the DevOps culture for different orgs that most think they already have, but they just don't. And a reminder for everyone that's watching that DevOps, quote unquote, as we know the term, is not a toolkit or a job description. It is a work culture and a mindset and an approach to the work that you do, right? So that being said, which we'll revisit that later, if you're thinking to yourself, man, why the fuck should I care about virtual machines? Everyone knows that those things suck. They're super old. I sincerely hope that you'll take a minute and reflect on what we said here a minute ago, which is that everything runs on top of an operating system, even if you can't see it, no matter what it is, right? And so not only do I believe that these abstraction comments hold, but there is a mountain of vendor software and free and open source tools alike that can actually run way more easily directly on an operating system. So for example, RStudio is a company which produces analytical software. They have this thing called Connect, and Connect is a platform that I recently helped re-architect to the client, and it hates to be run in containers. It's got file system fighting issues that it kind of deals with, and it gets better all the time, but it prefers to be run on disk directly. And if you have a long running service like a Minecraft server, and those things are really easy to run in containers, but they're really difficult to maintain in containers. If you try that latter one specifically, please reach out to me and let me know how it goes for you. I bet that it doesn't go as well as you hope. So the bottom line is, love them or hate them, or anywhere in between, operating system images are this familiar territory for developers, for security engineers, and for operations specialists alike, both new and experienced. So by enabling a shared build and release framework in such a familiar space as virtual machines, the accelerated adoption of quote unquote DevSecOps can become this reality with way less friction than if you try to launch directly into containerization from day one, like some companies do. And in general, by first introducing virtual machine build pipelines, you can bridge your workflow to other architectural future states, even if that future state is still virtual machines. Give me as I resize my speaker notes window. So what I want to do today is walk you through a few very true stories of scenarios that I've run into where I think Packer would have helped to solve for problem spaces, both of the technical and cultural variety. And see that I struck out the Kubernetes there and everything turned blue. It's Hollywood magic, kids. So who am I? That's me. I'm Ryan. The J in my my name there is because Ryan Price is a very common first name, last name combination. The J lets me stand out on LinkedIn. You can fight me about it. That's the way it is. I work for a company called Slalom Consulting. I'm on the local leadership team for that group in our cloud, DevOps, and security space here in St. Louis, Missouri. I've had a pretty diverse career over the time that I've worked in tech. So I started off in what the internet calls data science, so very statistical, very analytical, a lot of graphs and charts and modeling and machine learning, quote unquote, right? Then I started getting really into data engineering because I needed better data. To make better data, I needed to be a better software developer. So I started writing a lot more code and writing it well and writing tests. Got more into infrastructure because my code kept exploding. And then I got into cloud was the natural transition. And now I do a lot of stuff at the operating system level, sysadmin kind of things. By the time I talk to you next, I'll probably be writing like assembly code directly on a processor. This is kind of the path that my life has been on. Like I said, I work for a consulting firm that I've worked with companies at every stage of their tech modernization journeys. There's a lot of clients that I've helped move container platforms to container platforms. There's a lot of clients that I've helped move stuff from an on-prem setup in a data center to a better way to do it in a data center. I get to work with a lot of different folks who do a lot of different things. I was a pretty early pioneer in the space for containerization when Docker got super big a number of years ago, specifically in the data engineering space. There wasn't a ton of good resources online to help me understand what I was doing. So I got to write some of that and contribute back to the community and show what the possibility of doing data processing and pipeline and containerization could look like. Through all the work and all the different talks that I give and the open source projects that I work on, my personal theme is to automate everything, which is always a bit of a stretch because there's going to be edge cases where automating things is really, really difficult. But it's a theme that I carry with me to, again, the different talks that I give, the open source projects I work on, the client work that I help, the solutions that I help design for them. It's really important. It's really important to me, and it's really important to folks for realizing value. Forewarning, a lot of these slides are actually pretty boring because I'm not the most designer heavy person, but bear with me. Lots of cool stuff. We're gonna have fun. Okay, so going back to Packer, what does Packer actually promise to solve for? Well, at face value, Packer says that what it's ideal for is to build repeatable and portable public cloud machine images, right? These are things like AMIs on AWS or the pre-baked machines on GCP or Azure, different things like that. Maybe you'll build an image that has a ready to launch application installed. Maybe it'll have a database provisioned on it. Maybe you can build a set of images that serve as the base platform for other deployments like Hadoop clusters or, yes, even Kubernetes clusters, right? And with this single source configuration file, you can define the desired state of your output machine images and then build them into your target environments, even in parallel. Like Packer just by default takes everything and builds everything as parallelized as it possibly can. Packer creates a bunch of like temporary resources for these builder machines that do the building in your target cloud. It'll make the instance to build the image. It'll make networking components to let Packer's builder machine talk to the other builder, networking components and security stuff. And when it's done, it destroys all of that for you. What's really cool about that though is that in an enterprise setting where you want to be able to control what those networking components are defined as, what access one machine has to another in your corporate network, all that stuff is configurable in Packer. You can just tell it, no, I want you to use this security group, this subnet, this whatever. And Packer just knows what to do with that for some given public cloud provider. It's really, really flexible. I grabbed some images from the documentation. So on the left there, you have what I believe is now the older format for Packer manifest, which are JSON files. Define some builder stuff. How do you want to provision the images? Do you want it to be shell code? Do you want to run Ansible playbooks, stuff like that? And then on the right there, I just grabbed, again, documentation page showing you invoke the command Packer build out of this manifest file, which is on the left. And you can see there the different color highlighting, if you're able to see it, shows that it's building a VirtualBox and a VMware output image at the same time in parallel. I know we didn't talk about VMware and VirtualBox, but we will coming up here. So I know that the aforementioned Packer value add statement, right, alone by itself is pretty significant. It can do an awful lot of stuff in the virtual machine space today. But when I first started with messing with Packer a while ago, I had a really different use case in mind for myself. And so I thought, what other use cases could Packer help solve for? And I don't mean to make it sound any less powerful than it is, but at the end of the day, Packer is really just a set of wrappers around operating system level tools that you might use if you were doing everything manually, right? You might give some pre-seed or some kickstart files. and then a web server to get fetched from for your virtual machine to use. It sets up SSH connections, it runs shellcode. These are all things that you could do manually, but Packer provides this automated abstraction around them. And so really for any use case or target end state that you can imagine a virtual machine for, Packer can probably be made to get you there. So for example, out of the box, Packer supports a ton of what it calls builders. And what builders are is really just processes and plugins and modules that actually build an image in your target environment. It'll do that. The builder also understands where to store the output image file. It can report on the status of how the build is going and so on and so forth. And so some of those examples are things like the public cloud providers we saw before, AWS, GCP, Azure. It also supports builders for DigitalOcean, for Alley Cloud, and a couple others. And it even supports, again, completely out of the box natively from the open source projects, VMware, VirtualBox, QEMU, Hyper-V, macOS Parallels, and more. The last time I checked, there was like 30 default builders that Packer comes with, excuse me. It's pretty serious. And so what I wanted to do was I wanted to take a look at VMware first as a real life example, because a platform like VMware and other similar ones is something that's probably going to be familiar to an awful lot of people who work in enterprise, because maybe you're running this stuff on-prem, maybe you've got a VMware cluster in the public cloud, whatever. It's a pretty typical use case that we see a lot of our clients at Slalom specifically. So before I show those examples very quickly, here's the cast of characters that we have here. The more yellow circle is the developer. You'll have the gray circle, which is the operations team. And then not at all, underhandedly, I've decided to color the InfoSec circle red, not because they get in my way all the time, but because those are the colors of circles that I had, I swear. Okay, so now that we got the cast figured out, so VMware has this hypervisor software called ESXi. It's this really tiny operating system, but what it does is it allows you to run a ton of heavier, regular virtual machines, regular quote unquote, on top of a bunch of hardware, right? These can be distributed across these massive clusters of physical machines in data centers somewhere as a typical use case for it. And a lot of companies will use VMware's suite of different products to create and manage their own private clouds. Private clouds meaning it's your whole farm of compute and storage, right? In St. Louis alone, where I live and work, I've worked with at least one client like this. And a lot of it is because their industry kind of makes it difficult for them at their current maturity level to go to the public cloud. And that's okay. Again, people are at different stages of their journey all the time, and I get to work with all of them. However, this client does have like what I'll call an inefficient means of getting software from the conception phase to a production phase. So what they have is, in all things considered, decent private cloud on VMware. That private cloud is strictly used for development environments. So developers can go in, they can click a button in the self-service portal and then get a VM provision somewhere. They get emailed the SSH key and the IP address in 2 separate emails. And then they can just go out, they can rapidly iterate on stuff, they can prototype things, make POCs, whatever, all in virtual machine. They have sudo access on the box. It's kind of what you'd expect if you were to make like an EC2 instance, right? But when it comes to getting the same deployment into production, their entire stack needs to be reimagined for bare metal, not even on virtual machines. And on these boxes in production, they have no sudo access. There's no feedback loops to speak of. There's nothing. What happens is the ownership gets completely thrown over the wall, to use the old adage, to the ops team. What the developers do is they fill out this really lengthy technical architecture document, they submit it for approval, and then they wait 6 to 9 months to get a physical server provisioned, which is supposed to already have all their software deployed on it. And if there's a bug fix or a new version that needs to go out or anything else like that, oh, got to go submit a ticket. We'll get to it the next release cycle. Does this sound familiar to anybody else who's listening to this? I mean, like woof, right? It's a dumpster fire. And you can see there at the bottom, InfoSec is kind of creeping up, making sure that nobody's breaking any rules. So now I want to tell you about a different client of mine. Again, I had a handful of stories to share here. They're super early in their cloud journey, way earlier than this other than the other client I just mentioned, because they kind of just dove into the cloud. They didn't even plan it. So they're coming from these on-prem physical machines, not even virtual machines, I don't think. And there is a ton of legacy cultural carryover in terms of how siloed all the different teams are. For example, they're in AWS today. EC2 user data, the bootstrap code, is completely disabled. Developers are not allowed to use it. AWS accounts are vended for individual applications from an AWS org with service control policies, which is global IAM control, all of which is the right things to do, but they still won't give the dev teams any out-of-the-box IAM permissions in the accounts. So not only is there restrictions from the org, but there's nothing in the account. You have to basically build your own allows from scratch. The dev teams are responsible to do this themselves. They have to open PRs to Bitbucket for this to happen. It is absolutely infuriating, and it completely just kneecaps developers. It destroys their productivity. So what happens today is the developers will write some infrastructure code or some app code, they'll commit it to Bitbucket, and Jenkins, in this case, picks it up and runs some kind of pipeline on it, right? Hey, look, exciting, we're using GitOps, right? Quote unquote, everyone gets really excited about that because it's new in the cloud for them. But what happens inevitably is Jenkins will push the result to AWS, and 90% of the time, there's gonna be some obscure IAM error, and they're going to get blocked. The Jenkins will fail to build and their stuff doesn't get deployed. The developers are all new to the cloud and to AWS and to everything. They don't know what they need. They don't know what the errors mean. And so they freak out and they go and they ask the cloud ops team, which is essentially the operations team from on-prem that's been rebranded. And the cloud ops team just kind of chuckles, shrugs, and says, you need to go take that up with InfoSec. And then InfoSec creeps up there from the bottom of the screen and tells them to get fucked. Like it's just this massive triple dumpster fire. It is incredibly unhealthy from a cultural and workplace perspective in tech. And if that's how things are going to continue to be for them, should they be going to the cloud today? It's an open question. That's one of the things that I'm there to help them with right now. It's a very frustrating dynamic, and it's one of the things that that we get to do a lot, is to make sure that we can bring people forward into the environment they're supposed to be. But we see stuff like in patterns like this all the time. So ideally, how might these and really all similar scenarios look if we re-architected that whole system to put Packer into the mix of it from a tool set perspective, as well as from a cultural perspective, right? First of all, foremost, this assumes that you have like parity between a dev and a prod environment. So keep that in mind. So think about the first example. Well, you'll have that development VMware cluster, which would be used very much like it is today. Users can request the virtual machine, they'll get it provisions on the cluster, they get the access to it. But the difference here is that then the developer would take all the provisioning code that they were already running on the VM, like manually when they would SSH to it, and they would let Packer run the provisioning code for them. So they would generate an output image, they would boot, they would start their apps, they'd be good to go. All the same end result, but automated and stuffed into this tight little repeatable process, right? What makes this different though? What makes this really different? From day one, the development team should be working really, really closely with any ops team members, any InfoSec engineers, and anybody else who wants to have a say into what goes onto that virtual machine and how it's going to be deployed. And since everyone is centering around the idea of deploying something and working on something that's defined as code and stuffed into the same deployable package, every one of these teams and every member on those teams can all work together and look at the same time, make sure that everything looks the way that they want it to look and that everyone agrees from day one, right? The developers can get their code on the box. InfoSec can get the firewall rules onto the image. They can put their scanners, their linters, their Splunk log agents, whatever, all onto the deployed code. And then the ops team knows how to take it, make sure that they see what's going on it, and ship it off to deploy it into the cluster. There's no kicking it over to the wall. There's no failing security results, no whatever. Same working code as it works from how things were working before, right? This is the DevSecOps cultural transformation that everyone wishes to have. All the teams working together and everyone moving faster, right? Then, if they can get this process figured out, When it comes time to deploy to prod, everyone looks at it, everyone says, yeah, it looks good. They deploy it, it runs, it's shipping off its logs. Do they have to go through a separate process like requesting a physical machine in the future? No, they send the same image to prod, right? That's all you have to do because you already all agreed on the lower environment. All the same requirements are there, same image, same passing security scans, same working code, same deployment process. Everyone gets the same sleep at night, right? It just feels good, right? Because what does a process like that actually do? It brings teams together, right? And they get used to working together and not against each other. You take a familiar environment and you give everyone a hand in crafting a process in that environment. Because when it comes time to actually move to the cloud or to a more complex or abstract platform, teams are going to wish they already knew how to work together, because that's a whole different ballgame than just working together to get an image deployed into your secure data center, right? When these different org teams know what each other's requirements are and they know how to work together to address them, then the tech landscape suddenly becomes much more attractive and much less scary as companies move across it. Now, sadly, I don't have too much more time. And with all that being said, I did want to touch on what are some other possible applications for Packer once we see how it can really help solution for the cultural space. Well, my favorite one, which is what I picked up for Packer in the first place, like I mentioned earlier, is that I wanted to be able to repeatably build my own development machine, right? So whenever I would land on a client site and they give me a managed laptop, I really just want to tear my hair out because I absolutely hate developing on Windows, and I refuse to use a Mac because it's like Linux, but it's trying too hard. And so the first thing I always do is I try to get approval to install something like VirtualBox on my Windows machine, and then I'll slap something like Ubuntu onto it. And the major problem that I've been having for years was that not only did I have to redo this for every single client engagement, but sometimes a client host update would break my VirtualBox setup. I need to reinstall. Every time I had to go to a new client, I would forget to reinstall something that I had on the last one. That was like a core development tool. It was really painful. And so I picked up Packer for automating almost the full setup of my VirtualBox workstation. And it's been a total game changer. I can't believe I just said that. Logging into my Ubuntu desktop just feels like I'm opening up my own computer on every new client machine. It's super awesome. Now, this other example of what you might be able to do with it's a little more esoteric, but bear with me here. If Packer can automate the setup of virtual machines, well, then why can't you also use it to automate the setup of physical machines as well, right? After all, you're going to be running the same shell code or config management tool or whatever to configure the operating system, and Packer communicates over SSH by default. So why shouldn't it work, right? Well, as it turns out, there's no good out-of-the-box bare metal builders for Packer, nor is there a good one on GitHub that I could find. It's actually something that I would like to work on if I ever find the time, is to build a bare metal builder. However, while it's not super foolproof or robust, Packer can be used to automate building an operating system in a VM. So build it in the VM, and then you would convert the VM output to a raw format, and then use a tool like DD to just write byte by byte the virtual machine image to the actual physical disk. I have, in fact, done this myself. It works. It's not the most graceful, but it basically does what I expect it to. But why would I want to do that? Well, one use case could be for building these automated and repeatable output images for Raspberry Pi operating systems, whether they're clustered or just by themselves. This is most useful if you're not using the recommended Raspberry Pi OS, but it does have its merits there as well. Most people think of Raspberry Pis as like another similar system on chip computers as these hobby projects, but they're used in all kinds of industries, right? And they're really inexpensive. They're used in places like manufacturing automation, business display panels, order processing, and the ceiling of a Chick-fil-A. I'm not kidding. And lots of other stuff like that. I heard that there's a Kubernetes cluster full of system on chip things in like an F-15 fighter jet, is what I think is true. And so if you could automate the bare metal installation of these things onto the SD cards, Packer could be a tool to help solve for that, right? And now here we are coming back full circle to what we'd started the whole conversation with. Kubernetes needs to run on an actual operating system, right? Even if you can't tell it is because it's running on EKS or some other managed platform, And so by using Packer, this is my first major thing I did, using Packer, you can repeatedly build and reliably build the control plane and the worker nodes for a Kubernetes cluster, even all from the same build template. I'll be sure to share a link somewhere to show how I've written this before. I use dynamic shellcode to pick up which type of node Packer's building, whether it's a worker or the control plane. So the control plane nodes can boot one way, workers boot the other way. I'm actually pretty proud of the spaghetti code that I wrote for it. But the point is that Packer can basically create an entire control plane for you for Kubernetes, the starting parts. Now, I already spent the better part of 10 minutes, shitting all over Kubernetes for being way too complex. And so why in the world would I recommend it here? Well, like I said earlier, I do think Kubernetes is cool. I also believe that it's really overkill for almost every conceivable workload, quite frankly. And if you're looking for a workload orchestrator, even for containers, I would be remiss not to mention here at HashiTalks, HashiCorp Nomad, right? Nomad is this general purpose workload orchestrator. It can run apps, it can run batch jobs, it can run containers, yada, 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 all across the cluster of nodes, very similar in the grand scheme of things to how something like Kubernetes might do it. It's got this reputation as well for being way less complex than Kubernetes and only losing out on some of the feature set that the entire Kubernetes control plane provides. It sounds super rad. It's supposed to integrate really well with the Hashi stack at large as well. I've not used it myself just yet, but the last time that I was preparing this talk, there was that same week, a Hacker News post where people were saying how much they enjoyed using Nomad coming from Kubernetes. And that's really encouraging because it's one of those things where I'm finally going to have the chance to look into it and setting it up and automating that setup as soon as I get the chance to. Well, sadly, I only have 30 minutes here today to try to briefly evangelize a new way of thinking about architecture and how to approach that architecture in a way that is transformative in orgs early in their tech transformation journeys, all of which that could be enabled by Packer. But it's not really a new way of thinking, is it? Nor is it really a new technology outside of the facilitating tool. These ideas aren't new or revolutionary in and of themselves. These are lessons that are well documented elsewhere that I couldn't possibly fit into 30 minutes as a literature review. Teams chasing new and shiny buzzword tools has always caused growing pains when forward change is proposed, and change has always been and always will be hard for everybody. And that's the point, I guess. Remember that change is hard, but it doesn't have to hurt as much as you expect it to. Embrace a better work culture. Embrace technologic and architectural patterns that enable that culture. Love yourself, love your teammates, love your work. And as Dan McKinley has so eloquently put it in the past, choose boring technology, please. Thank you very much. Again, my name is Ryan Price. You can find me at RYAPRIC on most platforms. That's my first name, last name without the last letter. And thank you for coming by.